Today we're discussing the structure of the atom, and in this lesson we'll be discussing what the atom consists of, what the subatomic particles are, and where those subatomic particles are located at. Also, we're discussing the history of the atom structure and how that's changed. So let's get right into this. The history of the atom has been studied for the longest time. As early as, I guess you would say, 300 BC, with Democritus. He was a Greek philosopher. He believed that that all matter was made up of something small and indivisible, and then that made up everything else, like building blocks. And that's a logical deduction that he made. And of course, Aristotle, who came after him, said all matter was made up of earth, fire, water, and wind, or whatever. And of course, people said, "Hey, that sounds cool, so let's go with that." But he was proven wrong, and Democritus was eventually proven right. And actually, we get the word atom from Democritus as well. So let's get to the atom. The atom is as we say right here, it describes where and how subatomic particles are located. An atom is the smallest divisible particle that retains its chemical properties. So I can keep dividing compounds into their subgroups, and so I take sodium chloride, and say I had a whole salt container of sodium chloride. Well, they form crystals, and I keep breaking those crystals down until I get to sodium and I get to chlorine. And they each have their own chemical properties. But when I break down that sodium chlorine, which sodium looks like this. Sodium has a nucleus with 11 protons and 11 neutrons, and then it has these electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I add a third level, 3. So that's what the Bohr's model for sodium would look like. Now, when I break that down even more, and I remove protons and I remove electrons, I lose some of its chemical properties. That sodium no longer has its chemical properties. So there's that. So it's the smallest divisible particle that retains its chemical properties. Now, the properties, or the parts of an atom, consist of 3 subatomic particles, and then those subatomic particles are made up of some other things. Well, not electrons, but protons and neutrons are made of quarks, but we'll get into that later. So, the atom is made up of protons, which are positive, as you can read right here, neutrons, which are electrically neutral, and then electrons, which are electrically negative. Something I've already mentioned in class is that protons and neutrons form the nucleus. They are in the nucleus. As you can see in this diagram over here, I've got green and red, and that represents the nucleus. And so my green being protons and my red dots here being neutrons. Now, the thing with that is that all the mass of an atom, all of its mass, say I have an atom with a mass of 22, well, what is this atom? Let's look. It's going to be, I got 1, 2, 3, 4, 5, 6. So 6, that would be carbon. I've got a carbon atom here because I have 6 protons. Well, all the mass of this carbon atom is in the nucleus. Why? Because the mass of an electron is 1,840 times less. So it would take, the mass of 1 proton equals the mass of 1 neutron. They have the same mass. But an electron, I would need 1,840 electrons to equal the mass of 1 proton or 1 neutron. So say I have an atom here, and it has 1 proton. In order for this to get, so right now it has a mass of 1. It has a mass of 1. In order for it to get a mass of 2 with electrons, I would need 1,840 electrons to get its mass to equal to 2. So you can see why if I have 1 proton, 1 neutron, and then 1 electron, the mass is going to be 2 because these equal the same thing. 1 neutron and 1 proton is going to equal 2. And then 1 electron, it doesn't matter. I would need 1,840 electrons to do it. So again, that's just the mass. So let me erase all this. That's describing the mass. The mass of an electron is the mass of an atom is located squarely and only, or predominantly, in the nucleus where the protons and neutrons are located at. So again, if you look at this diagram here, this diagram right here shows me that I have protons and neutrons located in the nucleus. So we're going to call this the nucleus right here. Electrons are located outside the nucleus in the electron cloud. We're going to call this the electron cloud. So here's the nucleus. I'm outlining it in orange right now. This is the nucleus. These little blue lines represent electrons, and they are located outside the atom in this outside the nucleus in electron cloud. Now, to be honest, they don't really look like these concentric circles. This is an example of the Bohr's diagram, and we'll discuss that later. We're going to discuss the history of the atom now and what people first thought of it. They first thought the first atomic particle, subatomic particle to be discovered was actually the electron. J.J. Thomson, he did a cathode ray tube experiment, and he was able to, he took a tube, put gas in the tube, and he shot electrons. He did positive, negative, and he shot electrons through it, and then they went to the other side, and then he put magnets on either side. He put a positive and a negative magnet on either side, and he noticed that the electrons went. He noticed that some particle went towards the positive end, and so he's like, oh, there's something in there that's making it go to the positive end, so that must be something electrically negative. Okay, good. And so they discovered the electrons. It was really cool. But they didn't know what the atom looked like. They still didn't know what the atom really looked like. So the electron was the first subatomic particle discovered, so Thomson developed a model with electrons spread throughout the atom randomly. So what he did is he said, okay, if it's full of that, then... But he knew that there was something negative, but he also knew that the atom itself was electrically neutral. Something else was canceling out the electrons. He knew. He knew that the atom itself was, for all intents and purposes, electrically neutral. So while he isolated there was something negative there, he didn't know where the positive was. And so in his model, this is Thomson's model of the atom, right here. In his model, you have these electrons that are spread randomly throughout. Okay, it's sometimes called the plum pudding model. You'll see that in other classes called the plum pudding model. Now, we're not English, so we don't really know what plum pudding is, but imagine like a raisin muffin. That's what I tell the students. It's a raisin muffin with raisins spread randomly throughout the atom. Now, you see these obvious these negative electrons, and again, the overall charge is neutral. So he said, as you can see this little insignia right here, they're around the nucleus, or around the electrons, there's something positive, and it's uniformly positive. That's what they thought for the longest time. Well, his student, that was J.J. Rutherford, his student, J.J. Thomson, his student Ernest Rutherford, wanted to prove him right. So he went and he shot positive protons through this. And he thought, okay, if I shoot positive alpha particles through this, it'll just shoot right through. And because it's a thin layer of something positive, and it can shoot through the positive. Now, if it was a thick layer of something positive, it would bounce back, because positive repels positive. They go in the other direction. They repel. And positive attracts negative. We've seen that before. So he did this. It's called the gold tin foil experiment, and we'll watch another video on that. It was pretty cool. When he did this experiment, though, what happened is that he shot some particles. I'm going to make this little gold right here. Right here, let's make this a little bit gold so we can see the gold. That's a little more lime green, isn't it? That's about as gold as it's going to get. So he drew this gold sheet. He had this little tin, imagine tin foil, but made of gold. And he shot these alpha particles at it. Bop, 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 bop. Shot the alpha particles at it from a little box here. He expected them just to pass through. And most of them did. Most of those actually did. But what he found out is that they didn't all pass through. Some of them bounced back. They bounced back. And remember what I said earlier, that if it was a thick positive region, it would bounce back? He discovered that somewhere in this atom there was a thick positive region. We know that as the nucleus. So this right here, back up here, is the nucleus. It's a dense positive region. It's dense because it has all the mass. Now, because it has protons and neutrons are effectively neutral, the only charge that's in the nucleus is positive. So it has a positive nucleus. So Ernest Rutherford discovered that, and he proved his teacher wrong, which he was actually trying to prove him right, and he turned out to be wrong. So let me read this. Unfortunately for Thomson, his model was proven incorrect by the gold tinfoil experiment, which I just explained here. Ironically, Rutherford was trying to prove his theory, but disproved it instead. What Rutherford showed in his experiment was that there was a dense positive center to the atom, which I already showed you before, but here it is. So it was surrounded by negative electrons. But notice here that Rutherford still thought that the electrons were spread randomly throughout the atom. That is not the case. But they thought that for the longest time, that they were just spread willy-nilly, and that's just not the case. Then comes along Bohr. Niels Bohr, I think he was a Danish physicist. He was the first to determine that electrons occupied or surrounded the nucleus in specific levels called quantum. They are energy levels. So here's the nucleus, and then around the nucleus, electrons were specifically arranged in these things called orbitals or quantum levels. And so one electron here is a quantum level, and then I fill up that quantum level, that energy level, so higher energy electrons would go to the next energy level, and then electrons that were even more higher energy would go to another energy level. And so they weren't just spread willy-nilly, they were in specific locations called orbitals. So Bohr was the first to determine that electrons occupied energy levels called quantum levels. The energy levels are also known as quantum levels. He also determined that electrons travel up the energy levels when they get excited. So I take this atom right here, I have this electron right here, and then I shoot it full of some positive, or shoot it full of energy. Say the sun, something excites it, it gets hit with energy. Well, it has so much energy, it can no longer remain in the first energy level, so it travels all the way up here to the third energy level. There it is. But you know what goes up must come down, so it loses energy and goes back down. When it loses energy, when the electron loses energy, it loses energy in the form of heat and light, and light just travels away from it. So when it gets excited, it's called excited state. When it's called ground, when it loses energy, it goes back to its ground state, or the bottom state, the ground state. So quick review. The atom consists of protons, neutrons, and electrons. Protons and neutrons are in the nucleus. Electrons in the electron cloud. Actually, they're specifically in quantum levels. That's where they're really at, as we just found out. They're in quantum levels. But generally, they call it the electron cloud because they do float around there, and we'll discuss how they really look in the next video. They don't really just look like this orbit, the sun surrounding it by the electrons revolving around it like planets. Remember that the first subatomic particle to be discovered was an electron. It was found by J.J. Thomson. His student Rutherford wanted to prove his theory that the atom looked like just a ball with electrons spread randomly throughout it, with just a thin area of a thin region, a uniform region of that's just mostly positive, because he didn't know about protons yet. But that was proven incorrect. Ernest Rutherford discovered that the atom indeed has something called protons, and that's his gold tinfoil experiment discovered that. And then comes along Niels Bohr, and Niels Bohr was able to show that, as a matter of fact, there was those electrons did not just hang around randomly, that they were in specific levels called quantum levels or quantum energy. That's called the quantum mechanics model, which we'll discuss in the next video. Thank you.